All right, so one more day on section 6.4. So today we're going to look at how do you know something's exponential growth or decay? And then we're going to write some equations. So you're going to see a couple different types. So the first type will be a chart. And so you might have 1, 2, 3, 4. Like remember, the x's typically just go up by 1 each time. They could go up by 2s or up by 3s, but typically it's 1s. And it could start anywhere. It could start 3, 4, 5, 6. We don't really pay attention to the x column. The y's, however, are what we want to look at. Okay, and so we're just looking for, if it's exponential growth, the numbers have to go higher, so it is, that's a possibility. It's not 100%, and I'll show you in a minute. Decay, the numbers would be going down, but we want to look for, how do I get from 2 to 4? Well, that's times 2, and then 4 times 2, and 8 times 2. And so as long as it's the same thing, times 2, times 2, times 2 each time, then we would say that this is exponential growth. Okay, and then likewise, so it could, 3, 4, 5, 6. Doesn't have to start at 1. If I had okay, the numbers are going down, so it's either decay or it could be nothing. And so exponential growth and decay, remember the pattern has to be multiply or divide, so I don't even care about anything that's being added or subtracted. I don't even want to look at that. So 27, how do I get to 9? I would divide by 3. 9 divided by 3 is 3. 3 divided by 3 is 1. So, oops, this would be decay. Okay, and so if it could be neither. So if it was so let's see on this one. Okay, 2, 4, 6, 8. Like that's okay if it does that. Get that out of there. So you look at that one and say, well, it's going up, so it must be growth. But if you notice, this one is 2 times 2 is 4, but then this is 4 times 3, and this is 12 times 4. Okay, like there's a pattern to it, but it's not the same. So that's not growth or decay. It's none or it's neither. Okay, so you have a few problems to look at for that. Okay, and then it will shift into giving you some equations, determine if it's growth or decay, but then it also wants to know what's the rate as well. So you would say growth and 20% or decay and 18% or whatever. Okay, so you're going to look for the growth and decay part should be really easy. So for growth or decay, you're just looking at that number. You don't even care about the 28, whatever number that is in the front, it doesn't matter. So is that number bigger or smaller than 1? If it's bigger, it's growth. If it's smaller, it's decay. So that should be, excuse me, an easy part on this one. So it's growth. And then if it's bigger than 1, just look at the decimal after. So this kind of goes back to the last couple days. So I have a decimal of 0.3. And I want to change that to a percent. So I go 2 to the right. And there's a spot I have to fill. So it's growth, and it's 30%. Okay, and that would be it. You can just look at, okay, there's 0.3. Like that's how much bigger than 1, it's 0.3. We are saying how much bigger than 1 is it. It's just easy to do the bigger part because it's just whatever that decimal is after. So how much bigger, it's bigger, how much bigger? 0.3, which is 30%. When it's 0.2, 0.3, 0.4, 0.5, you're going to have 20, 30, 40, percent. Excuse me, we'll be with the charts. Is it exponential growth or decay or neither? So look for the pattern. Okay, the second group, is it growth or decay? And what's the percent rate of change? So is it bigger or smaller than 1? We'll tell you growth or decay. And then how much bigger? So if I had that one, okay, so 0.73 is smaller than 1, so we have decay. Okay, and then for the rate, when it's smaller, when it's bigger than 1, when it's smaller, you need to, it's like how much smaller is it? So really, I think the easiest way to do it would be just to do 1 minus 0.73, and you get 0.27, which is 27%. So you would have decay of 27%. Okay, so really over here, okay, how much smaller? Got to do 1 minus 0.73 to figure that out. It's not as easy to do as the other one, 0.27, which is 27%. Okay, so just remember that also, if you had, so this would be growth, because it's bigger than 1. And when you do 0.04, remember to change that to a percent, that's just 4%. Because when you move the decimal, the 2 spaces, okay? So the when it's 04 or 05 or 06 or 07, 4%, 5%, 6%, 7%. Okay? All right, so you have a section of those. The last 2 problems will be a fraction on the inside. So let's just look at one of those real quick. And so really you want to convert that fraction to a decimal. Okay, so if you can't do that if you don't know those, just 3 divided by 4. Like type it into a calculator. Do the top number divided by the bottom number, and you'll get 0.75. Okay, so that's smaller than 1. Decay. And so if you did 1 minus 0.75, you get 0.25, which is 25%. Okay, so the last two in this like section where there's equations are going to be fractions, and just divide them. Okay, so this one 3 divided by 4, 2 divided by 5, like whatever just do the top number divided by the bottom number. Okay. All right, and then the last section of problems that we're going to do, do these ones with the T for time. It's always been in years, like 1 year, 2 year, 3 year, 4 year, and that's or smaller than 1 will tell you the rate. Okay, so if it's less than 1, just subtract them with a calculator. If it's bigger than 1, you're just looking at the decimal after. Okay, and then the involves what's called compound interest. So the problems that we've been doing, typically not how things work. They're either like compounded monthly, or where every month there's an interest applied or a rate applied, or sometimes it's called quarterly, which would be 4 times per year. Okay, so we have a different formula that we use for compound interest. It's similar to what we started with. Okay, so the other one that we had that we used was like that. And A was the initial amount and R was the rate. Okay, so the P and the A really are like the same thing, but when we talk about interest, we're talking about like money in a bank. Okay, and so when we talk about money in a bank, that's called a principal. The principal amount. It's kind of the initial amount. Okay, and in the book, if you read where the formula is, it says P equals principal, and then in parentheses it says initial amount. Okay, and so the R is still rate, and again as a decimal. So we've done that. Okay, and the T is still time in years. But then the N is the number of times compounded in a year. Okay, so the P, the R, and the T are the same as what we did with the other one. The only thing now is we have this N. Okay, so if we had a problem that says you deposit $100 at 6% compounded monthly. Okay, so we want to write an equation that represents that situation. So we're not necessarily going to be figuring out after 10 years or after 20 years or anything like that. It just, let's set up an equation that meets that like criteria. Okay, so we have y, our principal amount is $100. Okay, 1 plus, okay, and so the rate is 6%. So remember we say 6% is 0.06. Okay, not 0.6. 0.6 would be 60. Okay, 0.06, and then the number of n is the number of times compounded in a year. If it's compounded monthly, there's 12 of them. And then the n goes up here also. Okay, so what we need to do is kind of simplify that stuff in the middle of the parentheses. So you're going to have to do two things. First, you're going to have to divide that 0.06 divided by 12. Okay, and sometimes it'll be nice, like this one's actually pretty nice. 1 plus 0.005. Okay, and so then I just need to add those together, and that should be simple. And there is the equation for this situation. So if you wanted to know, okay, well, how much money would you have after 5 years, then you would plug in 5 for t, and then you could work it out. And you'd have to do 12 times 5 is 60, so you're doing something to the 60th power, definitely using a calculator. Okay, so monthly, we're going to put a 12 for the number of times. Okay, first one. Last group will be, there's just 4 of them, where you're going to write an equation using that formula. Okay, let's look at another one. All the ones, I think it's all the ones, that you're going to do are going to involve depositing money. So it's, that's what compound interest is, dealing with that. So, so let's say $2,000 deposit at 3.5% interest compounded quarterly. So a quarter is 1/4, so it's 4 times per year. Okay, so using our formula, oops, that's not 12, is the last one. NT. Okay, so the principal amount is 2,000. 1 plus, okay, so 3.5, let's go over here. 3.5%. As a decimal, remember we move it 2 to the left. So I get 0.035. Looks a little weird sometimes because we have like 3 numbers where usually it's just 2, but sometimes that happens. And n is quarterly, so that's a 4, and a 4 in the exponent also. So again, your work is just in the parentheses there, 0.035 divided by 4. and we get 0.00875. And then the last part should be simple. You're just doing 1 point, and when you add it together, the adding part is always easier. Okay, and then there's the equation for that situation. Okay, so it's really, if you have the formula, it really isn't a very difficult problem to do. We've done the changing percent to decimal for a few days now, so if you're struggling with that, let me know. We can talk about it some more. Okay, otherwise it's just plug it in and use a calculator. Okay, so you'll have one problem, two problems that say compounded quarterly, one that says compounded monthly, so that's 12, and then one that will say semi-annually, which that means 2 times per year. Okay, so on that problem, plug in 2 for n in your equation. Okay, so 3 sets of problems. The first 2, all right, so hopefully, work your way through those. I've kind of cut out, I think, the ones that are a little bit more challenging, so I tried to make it as straightforward as I could, so hopefully you agree. All right, so have a good rest of your Wednesday, and we'll see you tomorrow. One last thing, sorry about that. You will have a quiz tomorrow over 6.1 through 6.4. So just a reminder, you have a quiz tomorrow on Big Ideas website. Okay? All right, talk to you later.